Yeah. Yeah, you're gonna get a lot of work time today. I want you to have a lot of work time today. Okay?
How many slides we got? 2? Ooh.
So
Good day.
So
It's like a third step day.
No, there are 2 slides. So you guys have a worksheet.
and homework and one problem.
And 1 problem from the book. Okay, so here's our graph. Okay, this is the graph of f. Please notice our function g. Let's talk about the relationship. What is the relationship with g and f?
It's
Okay, f is the derivative of g. Do you see that?
Yeah.
If we take the derivative of g, g prime of x is f of x. Okay, so the first thing I want to find is g of 1. Okay, well, let's imagine plugging 1 into g. That's the integral from 0 to 1 of f.
Oh, this is the graph of f?
This is the graph of f.
Okay, thank you.
Okay, so how are we going to find g of 1?
The area of 1 to
The area under the curve. Okay, if we're taking the integral from 0 to 1 of f, we're talking about the area under the curve from 0 to 1.
the time, which is 3 halves.
No, not 3/2. What is it?
Times 3.
It's 3 halves.
Wait, don't you have to do the negative area too?
What?
Well, we begin at 0.
Yeah.
So from 0 to 1, stop. That's the only area I'm finding.
But there's some more under
But I only want to go to 1.
You want to always go down.
Remember the x-axis that keys down.
Like
Here-
that rectangle right there? Like what?
This is the x-axis, buddy.
That's your trapezoid. You go to the x-axis.
We go to the x-axis.
We always went from like, we always calculated the negative area.
If you went to
yes
2,
or no.
then you'd have negative area.
Yeah.
Yes.
Oh, roasted.
Come on, bud.
If we went to 2, we'd have this red negative area.
Oh, Aaron. Down. Go cry. Whatever.
Okay.
It's still under it though, like.
Aaron, I'm trying to do something.
Okay, well, we're going to talk in a second. Okay, so g of 1 is 3/2. What about g prime?
0.
How did you get that, Zach?
Because that's referring to the derivative, which is just the graph of f. So where is f1? F is 0.
Okay, so the derivative of g is f. We established that up here. So what is f of 1? 0. Okay, now, what about, you don't talk yet. What about the second derivative? Think about it. Okay, Allie, say that. Okay, so if I want the derivative of f, here at 1, but the slope. Okay, so Nathan, what is the slope? -3. So the second derivative at 1 is -3. So the second derivative is referring to the first derivative of that graph right there. And so we look at the slope of the graph because the slope is the derivative.
How do you run this?
Right or run?
Okay, that's what I said.
Okay. All right, so now I want to know where g of x is increasing versus decreasing. Think about it. Think about it. Don't say anything, please. I want to know where g of x is increasing versus decreasing. Okay. So Emma, how are we going to decide where g is increasing?
I'm still kind of lost, so can I just like listen for a little bit?
Yes. Okay, let's go back to the relationship. Our graph is what graph for g? The derivative graph. Okay? Hold on. Do you have a question or a statement?
I was just wondering, I mean, like, if on other things that we could rewrite this, because I think it'd be easier to write things as F prime and F double prime, and then write it just as that.
Well, but F is G prime, so you don't want to write them as F. Like, we need to keep everything as G's because our accumulation function is what we're working with.
Right.
Okay? Zach, you had your hand up.
No, I was just going to answer your question.
Okay.
Oh, are we? So it's increasing from -1 to 1.
Okay, so you can second. We're increasing from -1 to 1 because that's where our derivative graph is positive. Thank you for your enthusiasm, Jimmy. Okay? So, Aaron, where is G decreasing?
Always gonna get a word.
From -2 to -1 and 1 to 2.
Because that's where the graph of the derivative is negative. It's all coming back to you.
Yes. He's gone too.
Yes.
Concavity. Think about how we determine concavity based on the graph given to us. Just think about it. Take it all in.
We are concave out, negative.
Hold on. I said hold on.
Negative.
Chill.
Okay, so first of all, Jimmy, let me ask you this. When we have the graph of the derivative, how do we decide where we're concave up?
When our slope is increasing.
Okay,
Still.
you combined two different ways to describe it. You either need to say where the graph is increasing or where the slope is positive. But you cannot put those together.
Rapid increase.
Okay, and so where are we concave up?
Oh, I got involved. -2 to 0.
Okay. Okay, and we know we're concave down where our derivative is decreasing, which is where, Brady?
Oh.
Jeez, it's where our derivative decreases.
That's where I was.
Okay,
So it would be 0 to 2.
good.
We got
What?
We got 10.
We got it. It is okay if you get it faster than other people. It is okay if you get it slower than other people, as long as we get it. Yes.
Do you like your other AP Calc AB class more than us?
What?
Like the other one you teach, like the AB.
We're the only. You're my only AD class.
That's why she can say we're her favorite in the class.
It's true.
Oh my goodness, I ended up in.
Okay, same graph, same function, new question.
It's like a -1.
Oh, hold on. I want people to like take it in, okay? Some of you get it a lot faster than other people, and I think that's awesome, but you need to look full time. Okay? Some people like draw things and write things down, and some of you just like sit there. So.
I just wouldn't know how to go about writing the notes. I just didn't.
That's all. That's your decision. Some people are trying.
I was
Okay, so I want to find g of -1, which, let me write this down, and you don't have to write this down every time, but this is what I'm finding. Okay,
Wait,
What is this? 4?
What is?
Where's
be flexible.
oh, there.
Oh,
Okay. So that means we're looking for the area under the curve from 0 to -1.
Thanks out, Eric.
That's 3 halves.
Okay, Zach said -3/2. Zach, why is it negative?
No, but you gotta.
Because we are going backwards. So yes, it's above the x-axis, so it's positive, but since we're beginning at 0 and working backwards to -1, that is going to be a negative area.
What about, okay, check this my question. Why do
We're working backwards because our function is defined as starting at 0 to whatever,
Oh, I see, okay.
okay? So you need to look at this limit. If this was 2, then that's like your starting point. Okay? Anything to the left of 2, you would be working backwards. Okay? What about g prime of -1? Johnny, what would that be? Why?
Because it's like where F would be, F of X would be.
Yes, that's where the graph is. Very good. Questions? Carly? Yes. So, this is our function g. The derivative of g is f. So this is our derivative graph. So at -1, our derivative is 0. Okay. All right. So I'm going to give you a worksheet that, of course, Mr. Drew will give you.
Problem while you're on.
I struggle with
Okay.
I'm an
I'll which one of those? Yeah, maybe I saw your post.
Okay. It's still recording, so I'll know everything that you said.
Maybe I saw your snap. 1:30 a.m. Come on.
Oh, yeah. You said it.
Okay. So my goal is for you to try to get this done in class. Now we have a few less minutes than usual. So we'll see how that goes, but I would like you to work together. Okay, put your heads together, be helpful. Explain something if somebody